Let's go ahead and take a look at some problems that have to deal with charge. So at the top right, I have written the mass of an electron, the mass of a proton, and the mass of a neutron, as well as charge. And we would probably want to go ahead and store some of these values into variables on our calculator just for handy usage. All right, so let's take a look. So suppose an object contains, it doesn't have to be an object, but a system contains 50 electrons and 40 protons. What is the total charge of the object? So we need to keep in mind that between 50 electrons and 40 protons, that these are opposite in charge. These have a negative charge and these have a positive charge. So net, since these are opposite, we would have a net of 10 electrons. So we are going to have a negative charge, and we take a look at our charge right here. Since we have 10 electrons times 1.6 times 10 to the negative 19, and this will be negative because we are talking about an electron, and we're going to go ahead and get negative 1.6 times 10 to the negative 18 after all is said and done. Let's take a look at the next one. Suppose an object contains 45 electrons and 70 protons. So again, these would have a negative charge. These would have a positive charge. So if we do 70 minus the 45, because these are opposites, we're going to get 25. But this will be a positive charge. So we'll have 25 times 1.6 times 10 to the negative 19th, because 10 to the negative 19, or 1.6 times 10 to the negative 19th is the magnitude of charge. And we'll go ahead and multiply that out. So typing that in right now. And we get 4.0 times 10 to the negative 18, but this is a positive charge because we had more protons than electrons. Suppose the system contains only electrons and protons. So we only have electrons and protons possible. There is a total charge of 20 plus 20 E. So this doesn't mean an electron. This means charge. So charge is this. So this is our little e. And it's going to be negative if we have a negative charge, and it's going to be positive if we have a positive charge. So if we have plus 20e, that means we have a net positive charge. Okay, so there's a net positive charge, and we have 150 electrons. And now we're asked, well, what is the mass of the system? So the first thing we're going to do is we're going to find, well, what are the number of electrons, and what are the number of protons that we have? So we're told explicitly that we have 150 electrons, but we know that we have a plus 20 charge, which means we have 20 more protons. So we have 170 protons. So it's asking for the mass of the system. So if we have 150 electrons, we look up here, and our mass of an electron is 9.11 times 10 to the negative 31 kilograms. Now, if we wanted that in grams, it would be 9.11 times 10 to the negative 28 grams, if we wanted it in grams, plus we have 170 protons, so plus 170. Now, the mass of a proton is 1.673 times 10 to the negative 27th. Now, if we're in kilograms for the electrons, we need to be in kilograms for the protons. If we wanted to switch to grams, we would simply move our decimal place over 3 times, because there are 1,000 grams in a kilogram. And we would get times 10 to the negative 24 gram for the protons. So if we type that all in, and you'll just have to give me a second as I do that. I'm going to go ahead and do it in kilograms, but it ultimately doesn't matter. Maybe we should just agree with kilograms in this case. But the context of the problem is going to be what actually determines what we do. So context is enough in here. So after I type all that in, I get 2.85 rounding times 10 to the negative 25th kilograms. So a very small weight. So we're talking atomic level, so we expect very small weights. All right, now we're going to throw neutrons into it. So suppose in the situation above that there is an equal number of neutrons as protons. So what is now is the mass. So we're going to take this answer because we've already done that, but do note then we would have 150 electrons and we would have 170 protons. And if we're saying that there's an equal number of neutrons, we have 170 neutrons. Well, the mass of a neutron is up here. It's slightly more than a proton, but not by too much. So the difference between an electron as far as weight and a proton is fairly large, however. So I'm going to just do this in kilograms again. Now, we would type all of this in simultaneously. So we have 1.673 times 10 to the negative 27th. And again, if you're doing kilograms, all of them need to be in kilograms. And we're saying neutrons are going to have the same amount. So neutrons 1.675 times 10 to the negative 27th. That's all in kilograms. So we already did this piece right here, and that piece was 2.85 times 10 to the negative 25th. So we just need to add in the neutrons. So I'll type that in. And hopefully you can verify. And I get a total of 5.69 times 10 to the negative 25th kilograms. All right, let's go on. Suppose the system contains only electrons and protons. There is a total charge of negative 40, and there are 300 protons. What is the mass of the system? So we have 300 protons. So our first step in this type of problem is figure out, well, how many of each of these atomic particles do we have? So if we have 300 protons, then we have a net negative charge. Well, that means we have 40 more electrons than we do protons. So if we have 300 protons, then we are going to have 340 electrons because we have a net negative charge. So now it's asking for the mass of the system. So we'll have 300 times 1.673 times 10 to the negative 27th if we're going to do it in kilograms, plus 340 times 9.11 times 10 to the negative 31 kilograms. I'm just going to do these in kilograms. I'm going to type that all in. And you can see that these are going to happen enough that it might be worth storing these variables somewhere on your calculator. So you can just type that rather than these scientific notations. And, oops, forgot one digit. Okay. And I get, in this situation, 5.02 times 10 to the negative 25th kilogram. Now, the next part, suppose in this situation there are equal number of neutrons as protons. Now what is the mass of the system? So essentially, we're going to take our answer. We're going to have 300 protons plus 300 neutrons, and we also had 340 electrons. So remember, a neutron does not have a charge, so it's neutral. We're going to add these up. So we already did this part right here, and we got 5.02 times 10 to the negative 25th. So we need to add to it 300 times 1.675 times 10 to the negative 27th kilogram. So I'll go ahead and do that. Takes just a little while to type in. And I get 1.8 0.00 times 10 to the negative 24th kilogram for that. Okay, so that's working with charge. Like if I'm using charge, I want to find mass. But now we're going to switch it up a little bit. We're going to talk about moles. So how much positive charge is in 4 moles of argon? So in order to do this, we're going to need to use the periodic table of elements, and we're going to look up argon. And when we look up argon, we're going to see that we have an atomic number of, so you will need your periodic table in order to do this, 18. So we're going to have an atomic number of 18, and we're going to have an atomic mass of, looks like 39.95. Now, in this case, we want the atomic number, because the atomic number tells us the number of protons that we have. So we have 18 protons in a regular argon atom. Now, we have 4 moles, so we're going to have to use the mole number, Avogadro's number, which is 1 mole equals 6.022 times 10 to the 23rd atoms. Okay, so how much positive charge is in 4 moles? So we're going to set up a factor label. If we have 4 moles, we're going to multiply, and there's 1 mole per 6.022 times 10 to the 23rd atoms. Okay, and for each atom, for each 1 atom that we have of argon, we're going to have 18 protons. And for each 1 proton, we're going to have 1.6 times 10 to the negative 19th coulomb of charge. So we have this long thing that we need to go ahead and multiply out. So I'm going to go ahead and put that in. Take me a second. So may make a mistake, but we multiply across, and in this case, I get 6937344 coulombs. We'll probably want to write that in scientific notation, so I'm going to say that 6.94 times 10. So let's see, 1, 2, 3, 4, 5, 6 times 10 to the 6 coulombs. We could write that in microcoulombs. That would be an option, but we'll get to that later. How much positive charge? So this is a positive charge. Of course, what would be the net charge if this is a regular argon atom, atoms that we're talking about? Then we would have 0 net charge because the electrons would balance out the protons, but it's asking how much specific positive charge there is. So we could assume that there's an equal amount of negative charge such that they cancel each other out. So this is our positive charge. You would do it the same way. If it said negative charge, it's going to be the same process, assuming that you have the same number of electrons as protons, but that's not necessarily always the case. So you would have to look carefully at your periodic table to know. You could have an ion where you have either extra electrons or not insufficient electrons to balance it out. So it just depends. How much positive charge is in 6 moles of nickel? So when we look up nickel on the periodic table, we would see that we have an atomic number of 28 and an atomic mass of 58.69 for nickel. Okay, so we'd look that up. We see this is the number that we're interested in because that tells us, again, the number of protons that we're talking about, and protons have to deal with charge. So how much charge is in 6 moles of nickel? So we're going to have 6 moles times, for every 1 mole, we're going to have 6.022 times 10 to the 23rd atoms, times, per 1 atom, we're going to have 18 protons, and then times 1.6 times 10 to the negative 19th coulombs for each one. So we'll go ahead, 6 times 6.022 times 10 to the 23rd. Might be worth plugging in the mole number as well into your calculator so that you don't have to keep typing that. Now, assuming I didn't mistype anything, I get 104.06016 coulombs, and that looks to be 1.04. Let's see, 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th coulombs. All right, almost done here. Now, what if we do the same thing but by weight? Okay, so from your notes, we just want to remember atomic number equals number of protons when we look it up, and atomic mass, that's going to give us the weight per mole. Okay, so let's try this. We have 30 grams of iron. So when we look up iron, on our periodic table, Fe, by the way, for iron, we have an atomic number of 26. So that means 26 protons, but I don't have the number of moles. So I need to change the mass to moles. So in order to do that, I need the atomic mass. The atomic mass is 55.85. Okay, so that means for every gram, 55.85 grams, I'm going to have a mole, 1 mole. And for every 1 mole, I'm going to have 6.022 times 10 to the 23rd atoms. And for every atom, I'm going to have, well, let's see here, 26 protons. And for every proton, 1 proton, I'm going to have 1.6 times 10 to the negative 19th coulombs of charge. So we had to first switch the grams into moles, then the moles into atoms, the atoms into protons, the protons into charge. So it was a big, long, nasty thing. So how would we type this in? Well, we're going to do 30 divided by the 55.85 grams. And that will give us our number of moles. Then we're going to multiply this answer by the 6.022 times 10 to the 23rd. So then we multiply that by our 26 protons, then that by our coulombs, and we get 1, 3, 4, 5, 6, 5, 0 point something. We don't care about that. This is coulombs. So scientific notation will help us out again. So we'll have 1.35 times 10 to the 6th coulombs. How much positive charge is in 50 grams of sodium? Hopefully you actually in chemistry studied your periodic tables. So you remember your elements. Sodium is Na, and Na has an atomic number of 11 and an atomic mass of 22.99. So if we have 50 grams of sodium, we're going to change the grams into moles. So 22.99 grams into moles, 1 mole, times, for every 1 mole, we're going to have 6.022 times 10 to the 23rd atoms. And for those atoms, now look, we have 11 protons. So for every 1 atom, we're going to have 11 protons. And for each proton, we're going to have 1.6 times 10 to the negative 19th coulombs of charge. Now, if this is a balanced system, we have an equal number of electrons as protons, then the net charge in the system is going to be 0. But we are specifically asked, well, how much of that charge is actually negative? Okay, so, positive. How much of it is actually positive? So assuming that it is balanced out. So here's what I get after typing it in. So we could round that, but ultimately I'm going to change this as scientific notation anyway. So let's see here. I'm adding my commas. So 2.305 times 10 to the 6th coulombs. And maybe we would round to this. Okay, those are good. All right, and that wraps up our section on charge.